So we have seen that the disadvantage with the non-contiguous allocation or the headache with the it is not a disadvantage. Okay, the disadvantage has been overcome by using something called as page table. We will see that the headache with non-contiguous allocation is we will not be able to perform a CPU will not be able to execute a process by using something called a simple addition. Okay, so because it is very difficult for CPU to keep track of the complete process because the process is actually not loaded in a contiguous address, whereas it is loaded in non-contiguous addresses, and so in case if it wants to go to some line, it is difficult for the CPU to do it using simple addition. So what we do is we do something called as page table. Now what page, the logic is actually very simple. Okay, what we do here is we have something called as page size. Okay, page size and frame size. We'll see that what we mean by this. We divide this is our RAM, right? This is our RAM. We divide our RAM into some fixed size into some fixed size blocks. Okay, which is what we mean by frames. Okay, for example, in case if we have actually decided that frame size equal to say 2 KB, what we do is we divide the RAM into 2 KB, 2 KB, 2 KB, 2 KB. See, I have not placed the process here, right? As of now, assume that our RAM is empty because it is not having even a single process, which means I have divided into 2 KB, 2 KB, 2 KB, 2 KB. All these are 2 KB, okay? 2 KB, 2 KB, 2 KB. So in case if I want to place a process P1, okay, see our process will also have logical addresses, right? It will start from 0, 1, 2 and so on. Now what we do is, in case if frame size equal to 2 KB, even the page size should also be 2 KB. Okay, always frame size and page size will be equal. Okay, in case if frame size equal to 2 KB, page size should definitely be 2 KB. Okay, see in case if we don't do this, what will happen? We will see that. Okay, we will see that. So what we do is we divide the pages, we divide the process into 2 KB blocks, 2 KB, 2 KB, 2 KB, 2 KB and all this. Okay. So what we say this as frames, we say this as frames. Okay. We are dividing the RAM into 2 KB blocks, right? All these blocks we also say that as pages. Okay. All these blocks we also say that as frames. Okay. The blocks of RAM we say that as frames. The blocks of processes we say that as pages. Okay, see what do you mean by frames and pages in real life? In frames, let us assume you are hanging a photograph inside in the wall of your home. Okay, now what we will have something called as frame, right? Inside the frame we will actually laminate the page, right? Which means we will place a page or photo over here and then we will laminate it using a frame, right? Which means we are actually placing the page inside the frame, right? That is what we are going to do here as well. Our RAM has been divided into frames, our process has been divided into pages, and page size equal to frame size. So what we do is we take the page and then we will place it inside the RAM. Okay, it need not be in contiguous addresses. See the addresses of a single page will definitely be in contiguous addresses. There is no doubt about that, right? For example, this is our page 1. Okay, this is page 1, page 2, page 3, page 4. Okay, see it will always start with 0. Okay, so that it will not confuse you. Let us assume this is page 0, this is page 1, this is page 2 and this is page 3, and similarly this is frame 0 of RAM. Okay, this is frame 1, frame 2, frame 3, frame 4, frame 5, frame 6 and frame 7. Okay, and also let's assume that as of now frame 1 is occupied means it has been occupied by some other page of some other process. Okay, some page of some process, some other process. Let us assume this is occupied, this is occupied. So we have 1, 2, 3 and okay, fine. This is how the RAM is present. Okay, now what we need, let us assume we are placing page 0 over here, page 0 of process P1. Okay, page 0 of process P1. Similarly, page 1 of process P1 over here, page 2 of process P1 over here, and page 3 of process P1 over here. Okay, this is how we have actually place the pages of process P1 over here. Now what is the problem here? The problem here is it is very difficult to go to a particular address of process P1 because they are placed in non-contiguous addresses, and it is very difficult for CPU to exactly find out the address of a particular line of P1, right? That is the disadvantage. Now what we do is we maintain something called as page table. Okay, we maintain something called as page table. Now what the number of the page table is nothing but it is a simple table. What is meant by table? It is a collection of rows, right? A collection of rows. Now what we do is we maintain a single entry or a single row for every page. Okay. For example, this page table will be maintained for every process. For in case if we have 10 processes, say P1, P2 and so on up to P10, for every process we maintain page table. Okay. This is page table of P1. This is page table of P2 and so on. This will be page table of P10. So for every process, this is very important. People generally get confused. Okay, for every process we maintain a page table, and so for process P1 we should have definitely maintained a page table, right? This is the page table of P1. Now the number of entries in page table of P1 will be equal to the number of pages of process P1. Okay, see, process P1 has been divided into 4 pages, 1, 2, 3 and 4. And so we will exactly have 4 entries in the page table of P1. Okay, we will exactly have 4 entries in the page table of P1. Now these entries will also be numbered. For example, this is entry number 0, this is entry number 1, this is entry number 2, this is entry number 3. See, we have exactly 4 pages and we have 4 entries. Okay, the pages are numbered. This is the page 0 of P1, page 1 of P1, page 2 of P1, page 3 of P1. Similarly, this is entry 0 of page table of P1, entry 1 of page table 1, entry 2 of page table P1, entry 3 of page table P1. Okay. Now what we do is page 0 of P1 will be present in some frame, right? For example, page 0 of P1 is present in frame number 0, and that frame 0 will be placed here. Okay. Similarly, page 1 of P1 will is actually placed in frame number 2, right? And so frame number 2 is indicated here. Okay. Similarly, page 2 of P1 is placed in frame number 4, and so frame 4 will be placed here. Page 3 of P1 is placed in frame 6, and so frame 6 is actually placed here. Okay, so that is the reason we maintain the number of entries in page table to be equal to the number of pages of process P1. Okay, this page table is maintained for P1 and the number of entries in it is equal to the number of pages of P1. Okay, fine. Now this page table of P1 will also be placed inside the RAM. Okay, it can be in any free space. I am not indicating it here. This page table of P1 will also be placed inside the RAM. See, even the page, anything which goes inside the RAM should go in terms of pages. Okay, so even this page table will also be divided into pages. Let us assume that this complete page table is actually big enough to we are able to actually place this complete page table inside a single page, okay, single frame of RAM. Okay, let us assume, see, I am not indicating it here. Let us assume that page table of process P1 is placed here. Okay, page table of process P1 is placed here. Okay, I am not putting this table here. You can think that this table is exactly present inside it. Now, how the CPU will actually execute a process? Okay, that is important. How the CPU will execute P1. See, we know that coming to non-contiguous allocation, in case if we don't have this page table, it is difficult for CPU to execute this process, right? Because it is difficult to keep track of address of every line of P1. Now here we will be able to do it.